All right, how's it going?
Awesome.
What?
Second week.
Second week. We can do this. It's good stuff. All right, so I'm taking attendance. Woo. So there's a little circle next to your name. That's the most important thing. Darken in that circle, okay, like number 2 pencil or something, and then just scribble your signature next to your name. And I made that list on Friday, I think, so everybody should be on there. Yes.
Pen?
Yeah, pen's fine.
Okay, for the BA1, do the function has to, the method, they have to be the same names as you mentioned them?
Got to be exactly like I mentioned in the assignment. The only thing that's optional is the reduce function. You don't need to implement that. It was just a suggestion. But add sub, mul, div, get num, get denom, and fraction, those all have to be verbatim.
Okay.
Otherwise, I got to modify my test programs, which I don't want to do.
Oh, yeah, I see what
Yeah.
you're talking about. Yeah.
Good question.
Yeah, because I changed some of the names.
Oh, okay.
That's why I was making sure.
To protect the innocent. All right, so other questions? Yeah?
So does like the ending fraction have to be reduced?
What do you mean by the ending fraction?
So if you would multiply 2 fractions, does like the sign off the output have to be reduced?
Yeah, it should be reduced. Otherwise, it's prone to blow up if I keep manipulating fractions but don't do whatever it is that causes you to reduce it. But again, if you reduce in your constructor, that'll kind of take care of itself. Because at the end of your add or sub methods, you've got to construct a new fraction or somewhere in there. And so if your constructor always reduces, then you're guaranteed to be in reduced form.
Just mean like every time it go each method like adding or subtracting, it just goes to the constructor and
Yeah, because your add method, for example, you have a fraction that you're using to call the add method, and you have an argument you're passing, and then you do your thing to add them together, and you've got to return a new fraction, right? And the only way to make a new fraction is to call the constructor. So it's going to run whatever's in the constructor, including reducing. Yeah.
So how to return net or double?
How to return what?
And or the double.
If you type this, right, exactly like that, uppercase double dot NAN with a little a, that is a double, right? If you have a double variable, if you're expecting to return a double and you return this, it'll be happy. And if you assign that to a variable, that variable will have the value NAN, which is what you want. So it's a special type of double. It's different from, 2.5, but it's still a double. It's just one of these reserved formats. Other questions? All right, let's talk about Euclid's algorithm. So, greatest common divisor of, I don't know, I should have come up with some test numbers. 125 and 20. All right, let's do 250 and 20. So what's the algorithm from CSE 215? So, well, that's a really bad example. Okay, so write your first number as something times your second number. Did I do another horrible example?
No, it worked. It's 14 times 3, right?
Yeah, but then it's exact. Yeah, at least one step. Okay. So let's do 63 equals, so how many times does 14 go into 63? I don't know. 28, probably like 4. That gets you to 56 plus 7. Okay, and carry these down. 14 equals 2 times 7 plus 0. Once you get to a 0, this is your GCD. And you do this as many times as you have to. So you're trying to find the GCD of two numbers, A and B. Remainder equals A modulo B, right? Which means you're saying A equals something times B plus a remainder. And now when we do this, you're going to say B equals something times remainder plus something else. So really all you got to do is redefine what A and B are, right? We can set A equal to B and B equal to remainder, and go back up here and do this again. Or you can do this recursively. The reason Euclid's algorithm works is because suppose we're trying to find the greatest common divisor of A and B. So we have some, let's say this is equal to F. So F divides A and F divides B. You thought you were done with 215, right? F divides A and F divides B. Suppose we write the following. A equals something times B plus some remainder. Okay, we can write this remainder as A minus something times B. Let me just call this X. Well, if F divides A and F divides B, F divides X times B, and F divides the difference of two things that are divisible by F, and so F divides all of this, which means F divides the remainder. So anything that is a common factor of A and B will also be a common factor of this remainder R. And since we know B is smaller than A and R is smaller than B, R is also smaller than A. So if we now try to find the GCD of B comma R, these numbers are smaller than those numbers. And we're going to stop when we get down to 0, and since each time our numbers are getting smaller by at least 1 after a finite number of steps, eventually we're going to stop. That's where we kick out of our recursion. So you can solve this recursively, right? See what the remainder is. If the remainder is 0, you're done. B is the GCD because it divides A, and certainly B is the biggest thing that divides B. But if the remainder is not 0, just find the GCD of B comma R, and that's your answer. So it's a tail recursion, which means you can do it in a loop, or you can write it recursively. And this you can exercise the heck out of without worrying about fractions or anything else. Just call it a bunch of times with a bunch of test values and make sure it's printing out the right thing. And stick to positives. Right, we mentioned that on Friday. So if you have a negative number, right, turn it into a positive, find the GCD, and then go from there. All right, did everybody sign in? Did anybody not sign in? Okay, cool. All right, does this make sense? So everybody can do Euclid's algorithm? Awesomeness.
Why don't we use negatives with that?
Because modulos with negatives sometimes gets quirky. If it works, cool, but I've never actually tried it with negatives.
It seemed to be working, so I was
Does it?
curious.
If it works, that's fine. I'm certainly not going to like say, oh, I use negatives, as long as it works. So I actually Have a few other test cases. In fact, let me go ahead and do that. So I've made a few extra test cases. I'm going to copy this file over to temp under the test sample main program. But here's some other cases to test your dealing of the minus sign. So different things divided into 0, a nan, which should not say negative nan certainly, and then different numerator denominator combinations of positives and negatives. Just some extra things to test. So I'll call that PA1 test B.java. So there's some extra code to work with. All right, we're going to move back to starting to talk about and work with linked lists this week, because you're going to need to use linked lists for PA2, which we'll talk about on Friday. And we're going to have a few, well, it's going to be in the afternoon, never mind. So let's think about stacks. Everybody remembers stacks, right? Because we deal with them in other courses as well. So let's make a stack class. So this is going to be our own class. And what I'd like to be able to do is the things that we did in 222 with stacks, but from Java. So I want to be able to say something like stack s equals new stack to construct a stack and call it s. And I could make multiple stacks if I wanted. And then I want to be able to say things like s.push some number, s.pop, which gives me back a number, and s dot is empty, which tells me whether or not my stack is empty. So s pop's going to return an int, and I would like my push to return a boolean, which will be false if it fails to push. In other words, if I'm out of space, and it'll be true if it succeeds. And we'll just implement with an array, nothing too fancy.
Is empty boolean as well?
Yeah, that's a boolean. All right, so how many people we got? 23 people, nice attendance. Let's do groups of 4. Let's go to the board, and we're going to write this as a class. You're going to write this as a class.
I can't find my phone. Don't worry. I win. I don't care, wherever you want. Hey. Watch where you're pushing, bro.
That's a moving board.
Should I? Yeah. That seems like a really good thing to do.
Did you? guys do that with you or not? Like a basic unit.
I can watch it on.
All right, so we're gonna do this one group at a time. We're gonna take turns putting this thing together. So I'm just gonna go around the room counterclockwise from above. We're gonna start with you. So so what kind of thing do we need to actually implement a stack? What kind of variable? How do we implement a stack?
With nodes.
Without nodes, with an array. What kind? Stack of integers, for simplicity.
Top and bottom.
So top and bottom is for a queue. So we just need a top of stack pointer, right? Okay. All right. So we haven't really done arrays, but take a shot at it. Can you make an array of 10 integers? Declaration of. All right, perfect. Thank you. So, so arrays in Java are declared with type of variable and then empty brackets, and then the name of your variable. And that declares it, but it doesn't construct it. You still have to do the malloc thing. So you can do this on one line or 2 lines. If you do it on one line, it's like what's on the board back there. If you do it on 2 lines, this is the declaration, and then you can say variable name equals new variable type, bracket, and how big you want it to be. And we're just making a stack of 10 things. So that will set up space for 10 integers. And you're going to put a class stack in the very beginning, right, to say we're defining a class stack class. All right, so next group. So what type of variable should our top of stack be? It's going to act like a pointer, but it's simpler than a pointer. There's actually no pointers in Java.
Just an integer that just says what index you're at in an array.
Exactly. So this is called a stack pointer, and it's an integer, and it basically says where is the top of the stack, what's the index at the top of the stack.
I have a question about the array.
Yeah.
application. Actually, is there any way to do that like dynamically sized, or no? It's just how
Yeah, that 10 can be a variable.
Really?
Sure.
Okay.
But you would need to do it inside a piece.
But you couldn't say oh, we've got 10 and we need more space to throw the array like that. Or?
If you do this new, it's creating a new array, but you could create a larger array and then copy the old one into it, for example, and there's things that'll resize that basically do that.
Is there an append in Java?
Append to the end of an array? There probably is, and you could certainly write one. All right, so so what should we call a stack pointer? Stack pointer? Okay, cool. So let's make this an integer. All right. Say again?
Will we do it a set value to indicate that it's a stack pointer? Or the other value is set to 0, right?
It defaults to 0, but when we construct the stack, we can actually give it a value, or we could give it a value here. Or we can just assume it's 0, but I don't like assuming it's 0, even though that's legal. All right, so next group. Should these be public or private? This array and the stack pointer.
Private.
Probably private, because we're going to, read from the array, write from the array, adjust the stack pointer. We're not going to really expect the caller, the user of this, to do those kinds of things. So I would make these private. And let's do a convention. Let's do this. I don't know how the pick processor do it, so we'll just make it up. Let's say the stack pointer equals index of the next push. So our stack will kind of look like this. So it's going to grow in this direction. The first thing that we push is going to go right here, and the stack pointer is going to get incremented. And the next thing we push is going to go into index 1, and the stack pointer is going to get incremented. And when we pop, it'll go the other direction.
So do you want stack pointer to start at -1?
It depends if we're going to increment it before we push or if we're going to increment it after we push. If we think of it as the place where we're going to put in the next thing, I would initialize it to 0, because that's where the next thing is going to get pushed. All right, so do you want to make a constructor? Yeah. So we're just going to call this thing by saying new stack.
All right, do it over here.
Sure.
We declare it first. So this constructor will be do we need to give it anything when we declare it?
Usually you say public to make sure it's public. And since we're constructing it without arguments, it's just paren paren.
Will we also add boolean?
For the constructor, you can't specify a return type, because it's going to return a stack, basically.
Oh wait, no, just stack.
What do we need to do in there? Almost nothing.
I don't know, I feel like it's pretty much taken care of right there unless we need to put something into it.
Pretty much. I would just go ahead and explicitly, go ahead.
Go make it take the size?
We could make it take the size. So I would explicitly set stack pointer to 0 just to make that clear. I mean, inside the constructor.
Oh, here?
Yeah. Right, just because it makes it clear that when you create a new stack, the stack pointer is 0. But that's almost a stylistic issue. Okay, so you had an idea of being able to specify how big the stack should be, right?
Yeah.
So can we have 2 constructors?
Yeah, we could.
Yeah. So, the hidden group. So, can you make a new constructor that takes an integer argument to specify how big the stack should be?
Yeah.
And then we want to set the size of our stack.
Yeah, so this would be a constructor, so it's going to be called stack. Cool.
You would just do exactly, but instead of 10, you would put size in.
We're going to make these private ones since the user's not going to use these variables.
So this is an interesting point. So in the class itself, we declared this integer array, right? There's 2 things. There's declaring it, and then there's actually constructing it with a new keyword. Okay? If we were to declare this array inside our constructor, it becomes local. And once we leave the constructor, it's gone. So we don't want to redeclare it. We just want to, inside our constructor, redo the construction of the array. So we're still going to use the same x that's up here, right? We're just going to repeat this x equals new, but we're going to give it a different size from 10.
Right.
We want to do new.
Yeah, we do new, which is like malloc, kind of.
n size.
Cool.
We don't need to return it, right? Because it's memory.
And you don't need to return because,
Okay.
yeah. Does that look reasonable? So with that in mind, we might actually take this construction of our array of 10 and actually move that inside our default constructor. So now when you construct a stack, if you don't specify an argument, it makes it an array of 10. If you specify an argument of n, it makes it an array of n.
So would you want to put it inside the constructor?
So I would put it inside the constructor. Otherwise, you're creating this thing, and then you're going to lose the reference to it. It's going to get garbage collected eventually. All right, so we have a stack class. We have a pair of constructors. So do you want to make a push function? So this is going to be a Boolean. All right, and it's definitely public because this is one of the ways that we want to allow the caller to interact with our stack. So I'll transcribe what they're putting up there. Awesome. Okay, so they're trying to write code to know if they've got a stack overflow. So they're saying if stack pointer. And you want to know if it's equal to basically the size of the array. And you didn't save the size of the array when you constructed, but arrays in Java have an inherent length. So we can actually say array, and it's a field, not a method, so it's actually just length without parentheses.
It just count how much.
And so if it's equal to that, we can say false.
So we're gonna go see the advisor today? Which advisor? WC? Yeah.
All right, so that's awesome right there. I won't make you write the whole push function. Let's go ahead to the next group. Can you write the part that's going to return if it's not a full stack? So what do we do if there's space in the stack?
I don't know.
So remember, stack pointer is the index of the next push.
So if we do, but if we do just like with
Perfect. All right, so here's what they came up with. If the stack pointer is the length of the array, we're out of space, so return false. Otherwise, array bracket stack pointer equals num, and return true. Oh yeah, and increase the stack pointer. So you can do a plus plus at the end. So sanity check, first time you do this, stack pointer is 0. This is going to copy num into stack pointer 0. It's going to go right there. That's what you want. And then stack pointer is going to increment to 1 to say next push goes here. If your stack is full, your stack pointer is going to be equal to 10. Right, because it was 9, you saved in 9, and then it incremented, so stack pointer is 10. And array.length should be 10. Right, the last index is 9, the length is 1 plus the last index, so that looks like a perfect check. Does that make sense to everybody?
What about a new geometry?
What about a what?
New?
New?
Yeah.
For where?
End of list.
There's no list, this is just an array.
Oh.
Yeah. All right, style note here. Do we need to say else here? No. All right, why don't we need else? Because if the if is true, we're going to return, we're never going to get here. So if you take these out, the advantage is this gets shifted over to the left. And it stops you from getting arbitrarily far over to the right. It's not wrong, it's no more or less efficient. The compiler will turn it into whatever it wants internally. It's just something that's an option if you like. And you can avoid extra nesting. All right, so that looks like a perfect push function. Do you want to write a pop?
Yeah.
All right, did you already do it? Oh, you're starting it, good. Okay. So pop returns an int.
You get the whole board, and you're writing on
Actually, no, you shouldn't.
Yeah, so it
Once that stack pointer That's not 5.
So where do we find the thing we want to return?
Yeah, it's like you guys have your own.
Stack is, less.
What was it?
So then you needed
we're just going to take the memory of
probably wants to work
our relocation 0.
You can just decrement stack pointer.
Oh, yeah.
And not worry about
Make an engineering setting.
whatever is
What
still.
are we doing for
Good question. So the question is, what are we doing for underflow? We're returning an int, right? So we don't have the option of also returning a flag unless we make some kind of composite return a new class. So we can say it's the caller's responsibility to make sure they don't pop unless the stack has something on it. And we can just insist that they call is empty before they call pop. So we could do two things. One, we could just blindly decrement the stack pointer and let things blow up. Or two, we could just return a 0 or something and let the user deal with whatever consequences they brought on themselves, but not disturb the stack pointer. So how do you know if the stack's empty? It's 0, or you can call the isEmpty function, which they're going to write for us in a moment. So let's just assume we're not going to worry about this for now. Let's just assume there's something on the stack if the user's calling pop. That's a dangerous assumption, but for simplicity. So given the value of the stack pointer, what index do we want to return?
Minus stack pointer.
Yeah, so we want to decrement the stack pointer and then return that value. Okay? The value in the array indexed by the stack pointer. So when we push, it's a post increment. And so when we pop, it's a pre-decrement.
This is question. This is our pop. Just decrement.
So X and stack pointer.
So X is the array, stack pointer is the index graph.
We don't pay the stack. So the return
All right, so they're checking to see if it's empty, and if it is, returning 0. Otherwise, returning minus stack pointer, whatever's indexed to that location. Make sense? Yeah.
What are we returning from the
value pointed to by stack pointer?
Yes.
Or the value of the stack pointer?
Value of the stack pointer is meaningless, so yeah, it's the thing in the array at that index.
So it'll be.
It's not meaningless, but it's not interesting to the caller. All right, does this make sense to everybody? So we push by storing in the array, we pop by reading from the array. All right, do you want to write an isEmpty function?
The value that it's going to be. So this would do it. You would know the. Your stack is one less than.
right? But if you decrement it here, then
Because you want to return the one that was pointing to before you decrement. So this would be stack minus or minus because you wanted minus stack. So actually this would work.
Yeah, right.
Just this one, yeah. Which one? Right, yeah.
yeah, could do that for sure. Either way works.
All right, does that look good to everybody? If stack pointer equals 0, return true. Next statement says return false.
I said less than or equal to 0.
That's probably even better.
Because if you screwed it up.
Because if you screw it up, it'll go negative. Okay, good. So if it's less than or equal to 0, return true. Otherwise, return false. Make sense to everybody? Yeah.
We did return stack pointer.
Oh, that was going to be my last question. Can you do it in one line? So they said return parentheses stack pointer less than or equal to 0. Right? This evaluates to a Boolean expression, true or false. If it's negative or 0, this will be true, it'll return true. If it's positive, it'll be false, it'll return false. So it does the same thing as that.
If stack pointer is negative, already it's not.
You don't. It's the user's own personal trauma to deal with. I wouldn't write an actual thing like this, right? So you should, in your pop, see if the stack pointer is negative or if it's already 0, and if it is, don't decrement it. And you should probably do something to be able to indicate that an error occurred. You could return null. That would be a nice little zinger, but I don't want to get into nulls right now. Okay, so there's a complete stack package, right? So again, when you pop something, it doesn't get removed from the stack. It doesn't get removed from the array. It's removed from the stack technically. It's still sitting in the array. But there's no way for the user to get to that because they can't say for I equals 0 to 9, show me element I of this array, because it's private. They don't have access to it. And unless you give them a way to look at things other than array bracket stack pointer, they have no way of looking at this stuff. So it's actually a little more secure in that setup. So let's just go ahead and play with this.
It's not like really massive.
So you can go ahead and sit back down, or you can stand. But we're done with boards. Alright, so if your array is the same length as n, then we can't push otherwise. We'll save on the stack and return true. And then our is empties. Is that our code basically? Do a weird flag there, bless you.
Thank you.
What happens if you underflow on the PIC processor? Do you remember?
Does it roll over?
Hey, what?
I don't remember. I was asking if it rolls over.
Effectively, it actually resets the whole processor. Goes back to instruction 0 and starts executing from the beginning. It's a really severe response. But it's like, obviously something's wrong. I'm just gonna like start the day over again.
You could use it.
So we're not gonna do that here. We could like halt the CPU. All right, so there's a stack class with notable lack of comments, but you know, I would put some comments in the top saying what this class does. I would put comments on all of the public methods, the constructors, and the push and pop and the is empty. I don't know why I called it stack.c. Hey. Alright, let's do a main class really quickly. Alright, so there's constructing a stack that will hold 5 things. I can push some things on here. right? And I'm never passing the stack to my push or my pop or my isEmpty functions, right? They're methods inside this object. So I can say s dot isEmpty, for example, to see if that stack s is empty. And I'm just going to say, well, s is not empty. Let's do a pop and just print out pop returns, and it'll tell us what it returned. And it should pop off -2, 8, 3, and 7. So there's our main class. We got 120 seconds to debug this. Does that look good? Compiles. Let's go ahead and run it. So what do we pop off? -2, 8, 3, 7, and then the stack was empty. So you just wrote a stack class. And the nice thing is, it's like nice and clean to use. Right, s dot push, s dot pop, s dot is empty. S equals new stack. Right, so this is a nice example of encapsulation. Right, everything we need to do with s is contained inside s. We've got information hiding, because if I try to do something like s dot sp equals some weird number, right, it should complain at me and say you don't have access to SP, so we can't get ourselves in too much trouble. And then we've got this controlled interface. Now if we come along next week and we decide I want to implement this with a linked list so that it doesn't have a fixed size, does anything here change?
Why is it not accept the real number?
Why is what?
Why is it don't accept the -1, 2, 2, 2, 3?
Because I tried to set s.sp explicitly and I don't have access to the stack pointer. Right, so it's not the value, it's that I was trying to interact with something that's actually private. Right, and SP is declared to be a private. So if I change this and I implement this with a linked list, does anything in this program have to change? I don't even have to recompile it. Right, it'll just run with a new class. Yeah.
So even with your constructor, when you set a length as 5, if you're not working with an unset length, it's not going to really care about what you chose for the length?
So the constructor that takes a number would probably, the documentation would say deprecated, does the same thing as the default constructor, and I would treat it exactly the same. I would just ignore the 5. So when you look at different packages, sometimes you see certain methods have been deprecated or replaced with new supersets.
So when you compile it, you don't have to compile these classes together?
No, so if the stack.class has been rebuilt for this, when I run main.class, right, it'll look for stack.class, it'll pick up the new stuff.
So then if we were making a tree and we wanted to do breadth first search, we just had to make sure that stack class that we made would be in the same direction.
Yes, yeah, make sure, or point to it, and we'll talk about how to do that. All right, cool. Anybody not sign in? Last chance on that. All right, awesome. I will see you tomorrow.